because it's a polynomial function. And from here we know that it will be 0 for x equals plus or minus 2. So -2, 0, 2. 0. At 0 will be -4 to the third, and here 0. And at both infinities it will be infinity. So what I did was I realized that when I set it equal to 0, I get plus or minus 2. I realized that the x-intercept will be, the y-intercept is when x is 0, so -4 to the third will be -64. And at infinities, so it's infinity to the third, which is infinity in both cases. So now we can continue with the first derivative. So f prime of x equals 3x squared minus 4 to the second power times 2x. So critical numbers only come from f prime of x being 0 because it will never be undefined. And we have plus or minus 2 and 0. So x equals plus or minus 2 and x equals 0. Now I have to study the sign of this, but I will never bother with this. It's a waste of time. These are only positive. So x to the left of x negative, to the right of x positive. Also, this is a symmetric function because f of negative x equals f of x, so the function is even. I make myself a note so I don't forget. It's an even function. So now I have to make sure that these two rows work well together. From infinity to 0, yes, that's correct. From 0 to yes, that's correct. From -64 to 0, yes, that's correct. From 0 to infinity, that's correct. Obviously, this is a relative minimum, or local. Now I have to determine the second derivative, which is more difficult, because it's a product. So I have to apply the product rule for this. So the second derivative. So I have 6 outside. First function prime is 1 times x squared minus 4 squared, plus the first function times the second one prime, 2 x squared minus 4. I don't have enough room, so I need to go here. So one more time. So 6 outside. First function prime is 1, so x squared minus 4 squared plus x times 2 times x squared minus 4 to the first power times the inner function prime. Yes, I will factor out an x squared minus 4. I have an x squared minus 4 here. And here I have 2x times 2x, which is positive 4x squared. So this will be 6x squared minus 4, 5x squared minus 4. So when we set this equal to 0, we have a lot. We have x equals 2, we have x equals -2, we have x equals the square root of 4/5, and we have the negative the square root of 4/5. Gee whiz. Okay, fine. So 0 here and 0 here. And how much is this? So the square root of 0.8, 40, yes. So the square root of 0.8, 0.9. Okay, fine, roughly, yeah. So -0.9 and 0.9. I also have to put in the function. So 0.9, of course, is going to be the same. So 0.9, 0.9, so that was squared, right? So it's 0.8, yeah. So 0.8 minus 4, everything to the third power. So -33, roughly. Okay. So now I have to study the sign of this, which is an absolute mess. I will have to, it's easier to put this in the graphing calculator to study the sign. Okay, so I have x squared minus 4, and then 5x squared minus 4. Okay, so I will put a number to the left of -2, so -3. So I got positive. I'm going to put negative 1.5. I got negative. I'm going to put 0 in, and I got positive. I'm going to put 1.5. It has to be the same because, and then positive, because it's an even function. Okay, so we have up, we have down, we have up, we have down, we have up. So these are all IP, 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 IP. 1, 2, 3, 4 IPs. Okay, so here's the graph. So -2, 0, and 2, 0. 0, 0. No, 0, -64. G. 20, 30, I'm sorry, 20, 40, 60, 64 here. And -33 at -1, -33. 2, 4, 33, somewhere here. Okay. So from positive infinity, opening up, crossing at -2, coming to an inflection point, changing concavity, opening down to changing concavity. Hold on 1 second. Do I have this point correctly? Yes. Changing concavity. But if it changes concavity here, oh, it changes concavity. That's, it would have been undefined, not differentiable there. So it changes concavity first, then it changes concavity here, and then the rest I don't need because it's an even function. So that's the graph. Any questions?